So here we go. We can look at another. We can look at another, example in finding the correlation coefficient here. And so we have done two of the example, and in the first two examples, you can see that our correlation coefficient are quite strong, right? I mean, it's what I mean in quite strong. What I mean by quite strong here is that in the sense that it's quite close to 1, right? So let's look at another one here and try to explore what's the other possibility for a correlation coefficient can turn out to be, okay? So I have the data set, the two data sets again, right? The data set for x and the data set for y. And this time I have up to like 1, 2, 3, 4, 5, 6, and 7 data points, okay? 7 data points altogether. So what I have here, what I see here is n equals 7, okay? And then so now to find, once again, we must find our mean value for all the x, okay? And so that is, according to my calculations, it's a 5.29, okay? And once again, you can always pause the video and do it yourself to verify with my calculation here. And then also I have found that the mean value for all the y values here is a 5.43, okay? And also I have obtained the standard deviation for all the x values, and that is going to be 3.04. And then the standard deviation for all the y values here that I have found is to be a 3.15. It's 3.15. Okay? So now, once again, with all these information here, I'm ready to find my correlation coefficient. So now, as a starting point to proceed, my n here is 7, so I have to do 1 over 6, because remember, it's 1 less than 7, right? And then I'm going to open my square brackets here, and what I need to do is, once again, I'm going to go through I'm going to look at my first data point, right? The x component is a 1, so I'm going to subtract x with the mean for x, so 5.29 is here, and divided by the standard deviation for x, 3.04. And I'm going to multiply that for, and what I have is a 10 minus the mean of y, 5.43, divided by 3.15. Okay? And then I'll keep going further, and keep going further. And so now you can see we have, in my second data point here, I'm going to be a little brief here. So 3 minus 5.29 divided by 3.04. Okay? And then I'm going to multiply with, let's say what do we have here? 9 minus 5.43, okay? Divided by 3.15. Okay? And then, I mean, so we have been through 2 examples already, so I know that, I hope you know what we're going to do next. So I'm going to leave the dots right here, representing that we continue on with the same, we kind of continue with the same kind of pattern here until we reach to the very last data, which is 10 for x, and minus, once again, 5.29, right, divided by 3.04, okay, and then times with 2 minus 5.43, okay, divided by 3.15. Okay? And then once again, I'm closing all my square brackets right here. And then I have to, once again, perform all that long chain of addition right there. And so now this time my calculation for the R value, okay, is, my calculation for the R value is a minus 0.95. So that means my R value, okay, is a minus 0.95. So now at this point right here, this is your correlation coefficient. To find the coefficient itself, once again, we've been through 3 examples. It's not that hard, right? So let's try to see some interpretation with this R value here. This time, I see a negative answer, right? And then furthermore, the value itself is quite close to -1. So you can see that's the observations, close to -1, right? So what's the expectation here? The expectation, right? The expectation here is that it's a negative relation, right? It's a negative relationship. Okay? It's a negative relationship. And then meaning, you know, as you decreasing your y values, I mean, as you keep increasing your y value, then your, I mean, if you keep increasing your x value, then your y values here will go decreasing. So that's one expectation. Or you can expect that besides being a negative relationship, you can understand that the data points are kind of like going down, right? It's going down to the right. Okay, that's how you can expect it.